All right, you see a 1 meter long balance beam. The fulcrum is 0.5 meters from one end, and there is a 2 kilogram bag of flour from the same end. How much torque of the fulcrum is being applied? Now I think let me try to draw this. So I have a balance beam like this, and then there's a fulcrum right here, and this is 1 meter long, and from here to here, this distance is 5.5 meters. And oh, there's a bag of flour on the same end. Let me drop my bag of flour. So right here, there's a big bag of flour. Now that flour is going to force this thing down at 2. It has a mass. This is my bag of flour. Flour equals 2 kilograms. Okay. 0.35. Oh no! Shoot. So I got to redo some of this. I'm going to have to draw this bigger because this is not long enough for everything to be seen. Wait, it actually might be right. Times by 10. Yeah, that's what I said. Why did you do all that? Yeah, why did you do all that? All right, so we'll try this again. You just do B equals RW. Okay, so this whole thing, the length of this is 1 meter. Right over here, from here to here, which is about 0.2 meters, there is a bag of flour. What color is a bag of flour? We'll say it's yellow. And that flour has a mass of 2 kilograms. And then also, way down here at the end, the distance from here all the way to this fulcrum is 0.5 meters. Okay, cool. So then it says, how much torque does the bag create? Well, there's a couple of things. There's some things that we have to think about. One is we remember that torque is equal to the radius times the force. Well, the force generated pushing down from the flour, this force that goes down, that force is equal to the mass of the flour times the acceleration due to gravity. So if I scroll down a little bit, so that force is going to be equal to 2 kilograms times 9.8 meters per second, or 19.6. And the question is what about the radius? Now, what we can do, it says 2.5 from the same end. Okay, so I wrote this down wrong. This isn't 2 meters or 0.2 meters away. This is 5 to this point here, and then from here to here is 0.2. So my radius then is actually 0.5 and minus you gotta be careful how you do this. It's gonna end up being 0.3 meters. So then you just plug that in. So then my torque would equal the radius, which would be 0.3. And so if you want to think of it, this is your radius. That is 0.3. And then that's going to be pushed down. And that force,
I went to a freshman year. I remember the freshman year.
that will have a force that pushes down. And so that force then is 19.6 newtons. And so when you do the math on that, I think it's 5.8.
No, it's GR.
5.8 8 Newton meters. And that's the final answer.
Oh, she's an actual fan.
I just think that the question's a little ambiguous because I thought it was 2 meters from this, but they're really saying 0.2 meters from that side is where the flour bag is. Okay, so let me zoom in a little bit so you guys can see that.
I said no, chill out.
Well, you just said you were
I told you no, and I told you.
I didn't ask. I know. I just said I know about Emma. You said what? Yeah. Oh.